This is question 4 on maths from section 2 of the 2019 BMAT. So we're told that the non-zero numbers p and q are such that p plus q is 3 times p minus q. And so we're asked the value of pq over p squared plus q squared. So where to begin? Well, let's start with the equation that we're given that defines p and q. So what would be a sensible way of manipulating this to form something similar to what we're asked for? Well, the fact that we have p squareds, q squareds, and a pq term suggests that maybe it would be a good idea to square this entire equation to see what comes out, because we wouldn't be able to get these terms otherwise. So let's square both sides of this equation. We have p squared plus q squared, p plus q all squared. And on the right hand side, what must we not forget to do? We need to square the 3 to get 9, and that's multiplied by p minus q all squared. So what next? Well, to get a term that looks like this and like this, we're going to need to expand both of these brackets out. So what is p plus q all squared? That is simply p squared plus q squared plus the cross term twice 2pq. And on the right hand side we have something similar. We have 9 times p squared plus q squared, because we have the minus times a minus, plus or minus the cross term 2pq. So this is a little bit messy, so let's begin to tidy it up. Let's keep the left hand side as it is, but multiply each of these terms in this bracket by 9. So we have the 9p squareds and the 9q squareds minus 18pqs. So we have the same terms on each side of the equation, so let's collect them together. If we get the pqs on the left and the p squareds and the q squareds on the right for now, that is 2pqs plus 18pqs to get all of that on the left. That gives us 20pqs. Then on the right hand side, we're subtracting a p squared and a q squared from the 9 of each one that we have here. So that takes us down to 8 of each. So let's do a quick reality check. Are we going down the right sort of path? Well, yep, we can see that we have all 3 of the terms that we need, the pq, the p squared and the q squared, and nothing else. And so it looks like we can get all of this on the left hand side, which would leave us with a number on the right hand side, which is exactly what we're after. So let's do just that. If we begin by dividing both sides by 20 to leave us with just a pq on the left hand side, and let's at the same time factor out this 8, that gives us 8 over 20 p squared plus q squareds. So we have 1 or maybe 2 more little steps to do before we have our final answer. Let's divide both sides by p squared plus q squared to make this fraction that we need. And at the same time, let's simplify this 8 over 20. How do we do that? That is the same as 2/5. So we know this fraction here is equal to 2/5 exactly. So that is our final answer, which corresponds to B.